All right. So here we today covered the second part of the chapter 9 lecture. Just as a refresher, in the first part of this lecture we covered the perimeter calculations of different shapes like triangle, rectangle, square, and circles, and we will talk about the area calculations and also volume calculations of the similar shapes in this part of the lecture. So what is an area? So area is a measure of surfaces of a plane of a figure. Okay, so how much surface you have in one plane. Okay, so when we calculate the area in general, we multiply multiple dimensions, especially 2 dimension. We multiply. So that's why the units of units of the area looks like inch square, feet square, okay, or meter square, because we multiply the 2 dimension, and both of the dimension will have the same unit. So to give you a little bit better idea, we have a rectangle here. So in this rectangle, you see there are 7 units along the horizontal line, and you have 5 units along the vertical lines. So if you try to think that what does it mean, for an example, let's say you assume that so you have 7 units, that means you should have 7 cells along each row. Row means all the vertical lines, right? So you have 7 rows. No, I'm sorry. Yeah, you have 7 columns. You will have 7 columns here because, and since you have 5 units in the vertical direction, you will have 5 cells here, and you will have 7 cells along the horizontal line. So if you think and look at carefully, you will see there are basically 5 rows and 7 columns, right? Because that's the only way you will have 7 units along the horizontal line and 5 units along the vertical line. Now let's try to count how many square you have, because you can see here we have different squares along different along different dimension. In total you have 35 cells. You can just get the number of cells just by multiplying the total unit along the horizontal line and along the vertical line. When you multiply 7 times 5, you get 35, right? That's how basically the square unit come into the picture, because you can assume in one unit as 1 by 1 square. Okay. For an example, if that unit is an inch, in that case the 1 square will be 1 inch square. If that is a feet, 1 square will be 1 feet square. So you can always think the area in this way. Okay, the idea behind the area. So there are several formulas we have for different shapes. Even for the same shape, we may have different formula based on how they look like, or based on what information you are given. Okay. For an example, to find the area of rectangle, which is probably the simplest, all you need to do is you have to multiply the length and width. Just make sure that before you multiply, they should have the same unit. Meaning they both have to have either meter, either centimeter, or feet, or inch. But they cannot be like, okay, one is 1 inch and another one is 1 feet. You cannot multiply 1 feet times 1 inch. You have to have either both in feet or both in inch. Same is true for all the area calculations. Make sure you have same unit when you are multiplying or before you multiply. If it is not, then we'll do the conversion first and then we'll multiply. Now the next one is for the square, which is again very simple. It's again we are multiplying two sides of the square, but as you may remember that all the sides of a square is same. They are equal. So that's why when you multiply, let's say s times s, it becomes s squared, because you have the same side or same edge in both as length and width. For the triangle, it's a little bit tricky, because for the area calculation of the triangle, you will need the base of a triangle, and you will also need the height of a triangle. When you know the base and height, you will multiply half times base times height. Then you get the triangle. Triangle is a little bit tricky, so we'll show you example how to do that for sure. So at this point we are just getting introduced with the formulas. And both of these are the formulas for calculating the area of circle. The first one is applied when you have to calculate the area and you are given the radius. You see here in the right side you have pi r square, right? And you know that the pi is a constant and the value of the pi is 3.14159, or 22/7, how you just want to do it in your calculator, you can do that. And the area of a circle can be calculated from the diameter using the second formula, because you see in the second formula right side, your diameter is given. So now it depends on whether you want to use the radius formula or you want to use the diameter formula. It depends on how the question is set. Even it doesn't matter if you just stick with one formula, because you know that when the diameter is given, you will definitely be able to find the radius, because all you need to do is divide the diameter by 2, get the radius, and apply the formula for the radius to calculate the area. So now it's up to you whether you want to learn two different formulas or you just always want to find the radius, because it doesn't matter whether you are given the diameter, you will be always able to find the radius. You see what I'm saying? So now it's it's simple, so it's up to you how you want to use it. But sometimes people want the straight formula, That's why we just wrote the two different formulas, but at the end it's the same formula. Here again we are trying to show you that how the area of a circle and triangle can be visualized, because we will be calculating using the formula, but at the same time we want to visualize how the areas are coming into the picture. As you can see from the triangle here, some of the circle, some of the square are not are half, right? They are not full square. But you can assume like this. For an example, you can assume that, okay, let's assume that these two make one, these two make another one, just getting the idea. And same is here. If you see near to the circumference of the circle, several squares are not complete. They are not complete square. They are half or either quarter. So, but you can imagine that how they look. They will make one. Let's say 4 make one, or sometimes 3 makes one. But at the end, you will have the formula, and you will be able to calculate it using the formula. This is just like how we can visualize the same picture that we have seen before for the rectangle, for in case of the triangle and circle. For an example, we are trying to calculate an area here to estimate the number of tiles required to floor a room that is 36 feet by 42 feet. Calculate the area of the room. Now, in general, what could be the shape of a room? What shape you think a room should look like? Mostly rectangle. I know that there might be some room that look like triangle. I don't know. But most of the cases it should be rectangle. Most of the cases. Maybe square is also okay. But triangle is a little bit weird. Maybe you will see some triangle as well. But let's say this is a rectangle, and all you need to calculate the area, all you need is the length and width. And from here you see the length is given, which may be 42 or 36, you can assume one is a length and other is a width. So when you multiply both according to the formula, you will have your answer. Now, we tried to give you a little bit more systematic way what you need to do. So let's say, for an example, from the question, in the step 1, we will try to find the correct formula. Once you have the formula, so we know that this is a rectangle, so we know that the formula applied here should be the formula of area calculation formula for calculating the area of rectangle, which we applied, and we substituted all the unknowns here. So we have L and W, and we know that L should be, let's say, 36 or W should be 42. It doesn't matter which order you assume, because somebody might think that, okay, L is 42 or W is 36, but at the end you are multiplying both numbers, so you will get the same answer. And the answer is 1512 feet square. Make sure you always remember the ID, which is, the unit, which always will be some square. Here we are again, now you assume that since you have 1512 feet square, so you will probably need 1512 number of 1 feet tiles, one feet square tiles, because the tiles have their own measurement, right? If you go to the store, they will say, okay, this tile is 1 square feet. Now how many square feet of tile you need? 1512 square feet of tile you might need. You might need, in real case, you might need little bit extra, because what happens is some of the tiles you have to probably divide, because all the tiles, if you look at the tiles here, how they are, at the corner you will see the tiles are not complete tiles, so they have some half here, probably the other half is somewhere else. So you might probably need a little bit extra, but theoretically that's what you should need. Now let's try some quiz question. What is the formula you should use for the area calculation of a circle?
Square. You said square, right?
I'm sorry, square, yeah. I don't see length times there, it's a length plus. So the right answer should be C, because you are multiplying 2 dimension, right? Remember, is in square, all of the edges are same, equal, right? So it should be S times S. S is just one side or one edge. How do you think? It's up to you. But sometimes you might see S square, but S times S or S square is the same thing. So that's the formula you should use. It's number C. How about rectangle? Okay, so the right answer is A. Triangle. It must be C, D, right? Because the triangle is a little bit weird. You half times base times height. When finding the area, the answer will always be in units. To the first power, cubed, squared, either cubed or squared. It must be squared, right? We always multiply 2 dimension. Doesn't matter what shape it is. You will be always multiplying. If you look at all the formulas, you will see there are 2 dimensions. Even in the formula of half times base times height, there are 2 dimensions, because one dimension will be coming from the base, other dimension will be coming from the height. So, right answer is C. What is the area of a room of 20 feet by 15 feet? This is a rectangle, so you'll be multiplying 2 dimension, and when you multiply, so right answer should be D, right? Is D, right? All right. What is the area of a triangle with a base of 2 meter and a height of 4 meter? Apply the formula. Half times base times height. You don't have to memorize any formula. When you go to pause, when you just
4 square meters.
so yeah, right answer is 4 meter square. So that it should be A, right? Half times base times height. When you open your question in pause or in exam, all the formulas will be given to you, okay? So when you will be solving the question, all the formulas will be given. So you will be given the formulas of everything, like all the circle, triangle, rectangle, everything will be given. So all you need to do is you have to find which formula you to use, okay? What is the area of a square of 8 meter on a side? 64 meter square, because you know a square has all the sides equal, so you are just multiplying their both sides, which will give you like 64 meter square. Right answer is A. Okay, let's try some solid shapes. Now, let's first try to understand what does it mean by solid shape. So far, the shapes we discussed, we have looked at, all the shapes have had 2 dimensions, right? Now, starting from here, all the shapes will have 3 dimensions. Now, remember, in the real life, all the objects that we deal with, they have 3 dimensions. For an example, if you think about this room, how many dimensions you have? Of course 3. Now how do you know it? Look at any corner of the room. Any corner, then you will feel it. For an example, you see here, along this line, this is a dimension, right? Along that line, that's another dimension. Along this line, there is one more dimension. Okay? So any object, for an example, any book, any, let's see, what do we got here? Let's say we might have, yeah, I might have something here. If you think this one, this is a 3-dimensional object. So there are 3 dimensions. One is along this line. You have 1 dimension, right? One is here, right? That's probably the height. What is the other dimension? If you look at here, there is 1 dimension here. So when you have 3 dimensions, try to match with the other sides. You will see other sides will be either of these 3. Any other side. So there will be 3 different sides for sure in any 3D objects. And you know, all the real life objects should be in general 3D. Okay? You know, we are fascinated by those 3D television, you know, 3D movies, 3D animations. What is the difference in the 3D? Because you feel like this. For an example, when you wear those glasses, 3D glasses, what do you see? You see the objects have different positions. You know, when even the screen is too far, you see the objects is like touching you because they have like one more dimension in addition to those regular 2D shape, right? So here we looked at some very common 2-dimensional objects or solids called prisms, cones, cylinders, spheres. Let's look at some. Let's look at all those solid shapes here. The first one you see, that's a cube. Okay, I think that this is also a cube, right? So it has 6 faces, and all. It's not probably cube. It's something similar to cube. I'll talk about this one later because it's similar to cube, but it doesn't have all the shapes equal. So it has 6 faces. All the faces are square. Okay, so they have 1 dimension here, 1 dimension here, and other dimension is this. All the edges you will see will fall either of this one. And think about this because you know sometimes it's really difficult to show you here because the plane we are watching all these objects is 2-dimensional plane. Okay, but if you have any kind of dice, you know, any kind of rolling dice, you see there are 6 faces, right? Because that's how in any dice you have 1 to 6, right? How many numbers you can have? 1, 2, 3, 4, 5, 6, because of their 6 faces. In one face we have 1 number, right? Now, this looks like, we all know a cylinder, right? We have seen the cylinder in several places. I think this is an example of cylinder here. It's a big cylinder. We have several cylinders here. And if you just take a segment that might look like exactly similar to this cylinder, that's a 3D object. So the solid that has two bases, because one base is here, other base is here. Those two bases will be a circle, right? Can you visualize? This base is a circle and this base is another circle, right? Top and bottom. And they are equal size circles and at right angles to the side of the cylinder. Because if you think that there should be a right angle, right? Between this edge and that base. The base is here and then edge is here, right? So that is a right angle. So you can think like that. And this is a cone. I'm sure that you also looked at the cone. When you go to the ice cream shop, a lot of ice creams have that kind of cone. And even if you buy the cones, that's how the name came into the name became cones. So it has one base. It's very similar to the cylinder at the bottom, but at the top it doesn't have that base. So it's something like a triangle here. So a TP is an example. So in case of the solid shapes, instead of calculating the area, we calculate the volumes. Okay, because it's three-dimensional. So the volume is the capacity of an object of the amounts it occupies. For an example, let's say, if you think about this, let's say the CPU, okay? This is a three-dimensional object. But if you think about this is taking a specific space, right? Space is extremely important to understand, because let's say you have to pack it and return it to the manufacturer. So when you pack it, you must know that what is the dimension of this one, so that you can find a box where you can accommodate this CPU. Now, how do you know it? Once you know that how much volume it has, what are the dimensions of all the all the three sides, then you will definitely find a box which can accommodate this one. Because you cannot fit this one into a box which has lesser value in volume than this one, for sure. But you can of course fit in somewhere which has more space than this. So that's how every object, like solid object, occupies some space. Okay, some space, and that the volume is a measure of that space. So the volume is in cubic units. So all the units will be coming like cubic feet, cubic inch, or cubic meters, cubic centimeter. You know what I'm saying? And from the cubic centimeter, you basically get those cc. When you buy, like, let's say a soft drink, what do you see? 500 ml. Have you seen it? Anyone? Okay. Now 500 ml is very equivalent to 500 cubic centimeter. That's how the cc come into the picture. Have you seen 250 cc? So that's basically cubic centimeter. People write it cc, but that's same too. Because all those things, when you go to, like, let's say you are trying to buy, let's say, any liquid like vegetable oil, you will see they write ml, 500 ml, or they write 1 gallon, but at the end you can again convert 1 gallon to liter, and the liter to cc. So let's try some all these objects. Let's try to understand their volume calculations. Here we have 1 cubic inch. Inch means, you can think it in this way. You can think that we have a cube here, and each dimension is 1. Let's say along this line we have 1 feet or 1 inch. This is 1 inch and this is 1 inch. When you have a cube of each dimension 1 inch, then in total that's 1 cubic feet. That's how you can think 1 cubic feet. That's a unit measure of the unit of the volume. Now let's look at their formulas and see whether we can apply their formulas. Remember, in this class we don't intend to prove these formulas, but we just know the formula, and we'll also know how to apply the formulas. So the first one, rectangular prism. Now this is the rectangular prism, okay? Because each side, each face is a rectangle. If you look at this face, this is a rectangle, right? This face is a rectangle. If you look at this face, this is another rectangle. All the faces are rectangles. So, in case of the rectangle, we just multiply their 3 dimensions. You know, we have length, width, and height. If you cannot identify which is length, which is width, and which is height, still you will know there are 3 dimensions. You just multiply 3 dimensions, and you will get the answer. Just make sure you write the answer in some cubic unit. Okay? And before you multiply, make sure that all the units are in same. All the units, all of those have the same unit. Like all of those should be cubic centimeter, or all of those should be feet or inch, or another unit. But should be same. You cannot multiply 1 feet times 1 centimeter times something else. Now, for the cube, since in case of the cube, excuse me, in case of the cube, all the dimensions are same. So that's why instead of multiplying 3 different dimension, we just write s cube, because we know that all the dimension is same. That's similar to a dice, right? You know, all the dimensions are same. Next one is a triangular prism. The triangular prism is similar to the cone. You know the cone, remember the cone, we just looked at the cone. It's similar to that, but it looks like this. Little bit different than the cone. Let me show you what it is. So remember the cone is this. Just be remind that it's the cone, right? The base is a circle and then that's a cone. But triangular prism is something like this. The base is a triangle. And then, can you visualize it now? Remember this side is at the other side. I'm saying, let me make it dot. That's in the other side. Can you visualize it now? The base is not a circle, but the base is a triangle. That's why it's called triangular prism. Okay. Now, if you look at the formula, still we have that formula of half times base times height. This base and height will be coming from the triangle. And the D will be coming from the length of the prism, which will be, for an example, this one, from the center to this point. Okay. We'll show you some example if we get a chance. Now, the next one, and also instead of doing this, you can also try this. You can calculate the area of the triangle. You know there is a triangle at the base, right? Just calculate the area of the triangle and multiply it with the height of the prism. Okay, this D is the height. Is the height of the prism. Just multiply with the D when you calculate the area of the triangle. All right. This is the cone. We know the cone, right? Now the cone, the volume 1/3. You see the pi r square here that is coming from the circle you have at the base, and this h is the height. So the h will be this, from the top to the center here. That will be the h, right? You can feel it, right? Which is h? That's the height from the bottom to the top. That's the height. In most of the question you'll be given those. In case of the cylinder, you have a pretty much similar formula for the cones and the cylinder. The only difference is, in case of the cone, you have a multiplication with 1/3, but there is no multiplication here. Excuse me again. You see the formula is same. In case of the cylinder, just to remind you, what is the cylinder? Right? And here, what is the R? R is this, the radius of the base. And what is the H? This is your H. Once you know the R and H, you know the pi is always a constant value, which is 3.14159. It's pretty much same. And this is the formula for calculating the sphere. Can you give me an example of a sphere? A soccer ball. The world itself is a globe, right? That itself is a sphere. Any soccer ball, cricket ball, tennis ball, all these are spheres, right? And all you need to know is their radius to calculate the volume, because everything else is constant, because you know the pi is a constant. So you just need the radius and then you will be done. Apply the radius and you will get the answer. So we try to show you an example of how to calculate the volume. Now in this example, let's say we want to first find the correct formula. This is a triangular prism. So let's say for the triangle, you have the base which is 5 feet, you have the height which is 4 feet. So when you apply here into the formula, half times 5 is base, 4 is height, and 6 is the height of the prism. So try to understand it, that the 4 feet is the height of the triangular base, and the 6 is height of this. Still there are 3 dimensions, right? Do you see the 3 dimension? 4, 5, 6. There are 3 dimensions here. When you multiply it, you will get the answer. So it's important when you get a shape, the first step is to find the correct formula. When you know the formula, you can just substitute the unknown by their values, right? And the remaining is simple. You just do the math in the calculator. And make sure you are applying the number with the same unit. And rest is simple. Any question here? Let's try another example. This is a cylinder, right? Can you recognize the cylinder? Because you know this is a cylinder, but we just we try to show you the cylinder, but in different orientation, right? It's not vertical orientation we have looked at here, but it's just a little bit oriented right. Now you have to first find the formula, which is pi r square h, and then find and apply the value. Now here the height is 20 feet, which you can see from here. But how about the radius? In the diagram or in the picture, you are given the diameter, right, which is 14. Since you know the diameter of the base is 14, what will be the radius? Must be 7, right? You divide the diameter by 2. So that's why in the formula you replace the r by 7. Do you see the 7 here? 7 is square times 20. Now you get the answer, which will be 3079. Answer must be in feet cube, because all the units are in feet. Let's try some quiz question here. When finding the volume of a container, the answer will always be in units. Right answer is B, right? It should be cube, because anytime anybody, any object you see, anyone is claiming the volume, that means the answer must be in cubed. All the volume should be in cubed. A square box 1 feet on a side will have the volume of what? Remember, this is a square box. Square box means what? You see the boxes coming from
1 feet.
So 1 feet cube, right? Because all the sides are 1 feet each. And since this is a square, that means the object is going to be a cube, right? If one surface is a square, that means it's a cube. So when you have a cube, what do? You multiply. There's 3 sides. Now each of the side is 1 feet each. So you multiply 1 feet times 1 feet times 1 feet. You get 1 feet cube. So the right answer is A, 1 feet cube. A rectangular box, right, with a width of 2 feet, length of 4 feet, and a height of 3 feet. So 3 dimensions are given. All you need is to multiply all the dimensions in the same unit. So you have the feet for all the numbers, so you just multiply them. 2 times 4 times 3. It should be 24 feet cube, right? When you multiply 2 times 4 times 3, right answer should be D. what is the volume of a pup tent that is a 3 feet width, 7 feet long, and 5 feet tall. Now how the pup tent look like? Any guess? Tent. Guess the tent. How does a tent look like when you go for the camping? Or that should be triangular prism, right? You have to understand the object. As when you understand the object, you are done, because you will have the formula for that. Now the triangular prism, what is the formula? Half times base times height times diameter. So you basically multiply all the three dimensions times half. So the formula should be half times 3 times 7 times 5, right? There are 3 dimensions given. So the right answer should be 52.5 feet cube. Right answer is B. Everyone has the answer? $52.5 feet cube, right? You have the answer? Alright, so let's go to pause and try the remaining parts of the homework for chapter 9.